All right, we're working with absolute values today. So consider the absolute value equation. Absolute value of x equals 3. Remember, absolute value is a distance from 0. What could x be then that would make this true? Well, x could be 3, of course, if I just plugged a 3 there. Absolute value of 3, of course, is 3. But what else could it be? Well, it could also be negative 3, because the absolute value of negative 3 is also 3. So I've got two possible solutions there. So in general, as we want to solve absolute value equations, here's a key. Isolate the absolute value. Get the absolute value expression all by itself. Then you're going to write two equations. Alright, it's the 2-for-1 deal. Solve the equations, check your solution, see what you've got. Let's look at an example. Solve the absolute value of 2x minus 1 equals 7. Well, the absolute value is already isolated. And that means this expression's by itself. I don't have any coefficients or added, subtracted, anything on this side, so it's already isolated. We can write our two equations. I like to call the positive and the negative case. Positive case is basically the exact same equation, just get rid of the absolute value. 2x minus 1 equals 7. Pretty straightforward. The negative case, notice what's different? You just set it equal to a negative number. Just like up here, x could be the positive, x could be the negative. So same thing. Another way to think of that is saying the opposite of 2x minus 1 could also equal 7, and then just taking that negative over, okay, dividing by a negative. So let's solve these two equations. Add 1, so 2x could equal 8. Divide 2, hey, looks like x could equal 4. Let's try this one. Add 1, notice the steps are going to be the same. So 2x equals negative 6, divide 2, x could be negative 3. Let's check those just to verify. So if I put a 4 in here, 2 times 4 is 8 minus 1, that's 7. Absolute value of 7 is 7. Hey, that's true. What if I put my negative 3 in? Well, I'd get negative 6 minus 1, I'd get negative 7. Absolute value of negative 7, also 7. Hey, those are both true. So notice I get my two solutions. What if you run into something like this? You have an absolute value expression that equals a negative number. Is there anything I could plug in for p that makes that true? No, there's not, because remember, this expression is going to turn things positive. Not to be confused with the case we just looked at where I wrote a positive and a negative case. The absolute value itself cannot equal a negative number. So this is simply no solution if you run into something like that, okay? Now let's solve this guy. Notice it's just the same as we just did, it's just a little bigger, and here's where I want to kind of reiterate. You've got to isolate the absolute value. So first, let's subtract this 5 over. If you don't, by the way, you'll get half the problem correct, but the other half you're going to be wrong. So that would be 14. Now let's divide 2 by both sides. And now I've got 2y minus 1 equals 7. I feel like that's the same problem we just solved. Let's go look. Right? 2x minus 1 equals 7. 2y minus 1 equals 7. So it's actually the exact same problem we just solved. But notice it started with a bigger expression, so now you would go down and solve it from there. If you didn't, by the way, the positive case is going to work out the same. It's the negative case that's going to be wrong when you solve it, okay? So again, just to reiterate, make sure you isolate that absolute value. Okay, what if we throw inequalities into the mix? So solve and graph 3x plus 6, absolute value, greater than equal to 12. Well, you solve them the same way, okay? One little thing I'm going to show you. So let's write our two equations. 3x plus 6 greater than or equal to 12. Here's the negative case. 3x plus 6 less than or equal to negative 12. Because when I put a negative here, if I divide it by both sides, you've got to reverse your inequality symbol. That's really the key difference. And now you just solve these two equations. So subtract 6. So 3x could be greater than or equal to 6. Divide that 3 over. So x could be greater than or equal to 2. And same thing, let's do these steps. So 3x less than or equal to negative 18. Divide my 3 over. X could be less than or equal to negative 6. Let's go ahead and make a quick graph. I think that really helps visualize, and they asked us to do it. So negative 6 and 2. We want less than or equal to negative 6. So less than or equal, so that's everything that way. Greater than or equal to 2. So that's everything that way. Hey, this looks like an OR statement, doesn't it? So you could say x could be less than or equal to negative 6, or x could be greater than or equal to 2. And that's kind of a common thing you'll see. When it's a greater than up here, it's going to be an OR statement. Your solution is going to be going opposite directions. Just a little pattern that you'll probably pick up. How about this one? 2x plus 7 is less than 9. Well, 2x plus 7 less than 9. Just write your two equations. 2x plus 7. Can you see what we're going to do here? Greater than negative 9. Notice I had to reverse that one for my negative case. Now you just solve them like normal. So minus 7. So 2x is greater than what? Or less than 2 there. And then let's divide that 2 over. So x could be less than 1, it looks like. Subtract 7, subtract 7. So 2x is greater than negative 16. Divide by 2. And x is greater than negative 8. Again, let's make a quick graph. Let's picture this. So negative 8, there's my 1. So x is less than 1. So that's everything that way. Greater than negative 8. That's everything that way. Ooh, can you see what's going to happen? This is an AND statement. So it's a sandwich between these two things. So you could say x is greater than and, or you could actually just write it this way. However you want to do it. Okay, x is sandwiched in between negative 8 and 1. Alright, one more problem let's look at. What's the solution? Now, solve it the same. I just want to do this to, again, reiterate, emphasize. Isolate the absolute value before you solve it, okay? So let's take that 2 over. Otherwise, you'll get the positive case right, the negative case you're going to be wrong. So we now have 4 times this guy is less than 12. Divide our 4, divide our 4. So here's my actual equation I'm interested in solving. Is less than 3. Now I could write my two equations, and really from there you can go solve it, but I'll go ahead and work it out. Maybe encourage you even pause the video, try it on your own, and see what you come up with. So let's subtract 6, so 3x less than negative 3. Let's divide there. X is less than negative 1 looks like. Subtract 6, subtract 6. So greater than negative 9, divide our 3, divide our 3. X is greater than negative 3. So, again, they didn't ask me to, but I'm going to do it. I think it helps picture. Negative 3, negative 1. We're greater than negative 3. I'm going that way. Less than negative 1. Going that way. Hey, it's an AND statement. And so I could do my sandwich. So negative 1, negative 3. That's really how I would write it. Or you could just say x is greater than and it's less than. But really this is a just a more concise way to go ahead and do that. Okay? So isolate your absolute values, write your two equations, solve them. Always a good idea. Check your answers.